All right, hey everyone. Thanks for coming to the very late session that we have today. I'm Eric Peter. I'm one of the PMs on the Mosaic AI platform, and I look after our GenAI observability and quality monitoring story. So I'm here today with.
Hey everyone, my name is Niall. I'm a data scientist on our professional services team, so I work directly with our customers to design, build, deploy GenAI applications. So yeah, we're going to walk through what it looks like to potentially do that on Databricks and some of the challenges and what are the things that we can do to help you get there quicker.
So what we'll talk through today is I'll spend a little bit of time kind of laying out some of the challenges with achieving business value with generative AI. I'll then talk about how we can apply some of the software development best practices that we've had for many years to generative AI. But the bulk of the time today we'll spend introducing MLflow 3, which we announced in the keynote earlier today, and going through a real-life production application use case and showing you how you can use MLflow 3 to measure, evaluate, and improve the quality of your production application. So with that, the biggest challenge that we hear from customers around generative AI is my agent or is my application actually delivering accurate answers? And this matters a lot, particularly for the use cases that we work on with our customer base here. And so if you don't have good quality, you can't have business value. And in fact, you often introduce a lot of risk if you don't have accurate answers. So one customer that we worked with, they're a major food delivery service. And they have a GenAI agent that helps improve the efficiency of their support team and it answers customer questions directly. And so if that bot gives wrong answers, it leads to a negative customer experience, which leads to churn. And also, if bot gives wrong answers, it leads to an escalation to the actual human agent, which drives more cost. So quality means business value. And so what this leads to is, well, how do I actually improve my agent's quality? Like how do I achieve the quality answers that I need? And so if I rewind maybe about 10 years or so, the question we would hear about 10 years ago is, well, how do I actually get my software application to behave reliably? And there are a lot of parallels here, right? My software application behaving reliably, my generative application reliably giving accurate answers. And so with software, we have a pretty well-oiled formula at this point, right? You write some code, you test it locally, you write unit tests, maybe you wrote them before if you're doing test-driven development, to do some QA testing. In production, there'll be telemetry and observability. And it's kind of crazy. I don't think anyone in this room would be able to go to their CIO and say, we shipped a CRM application or another business-critical application without at least having some form of this process in place. And so, this is it'd be great if we could actually take what we have in software and apply it to GenAI. But unfortunately, software is deterministic, right? If I click on the button, it's going to work or it's not going to work. In GenAI, it's not a deterministic system. And so that brings in some new challenges, right? So the inputs to the application, it's free-form language. In my software app, I know if I can either have them click the button or not have them click the button. But in GenAI, it's an open-ended input. And similarly with outputs, I actually need a domain expert to say if the answer is right or wrong. There's also this element of being able to tune between what's my quality and what's my cost and latency, right? I could throw a really high-end Claude 4 Opus model at the problem, but that's really expensive. How do I manage that balance? And so what this brings me to is that, what a lot of folks we see doing, unfortunately, are just doing vibe checks of their application. And saying that you launch a GenAI application with just vibe checks is the equivalent of telling your CIO that you've got a business-critical CRM application that you've spun up on your local dev box, and yeah, you click through it a few times, and seems like the data's being written right, and yeah, we launched it, which is almost crazy, when you kind of put it in that framing. And so in this talk, we'll talk through kind of evals and how you do both evals in development as well as evals online to give you the same software development lifecycle, but for generative AI. And so, this is where kind of the MLflow 3 set of capabilities that we announced earlier come into play. And so MLflow 3, we completely redesigned it for the generative AI era. We integrated it with the Databricks agent evaluation capability, which is our suite of proprietary quality evals and monitoring capabilities. And we've made it production ready. It's ready for production scale. And so rather than kind of go through a bunch of slides and tell you about all the MLflow features, what we'll do, as I kind of alluded to earlier, is we'll actually go through the life cycle of a real production use case. And so our customers, one of the most popular use cases, right? Everyone's got customer support. So everyone wants to make their customer support teams, operate more efficiently and deliver better. So in this use case, what we'll do is, I'll act as the PM, and Niall will act as the developer. We'll kind of go back and forth, kind of throughout the life cycle, see some of the challenges, see how MLflow helps. But to frame this use case, when we started building this, our CEO came to us and she said, "Well, look, guys, I care about two things. Did we increase our customer satisfaction score? And did I increase the amount of calls that were resolved the first time the customer called in?" And so if you've worked with a call center before, right, this is what the business cares about. They don't care about any other metrics than these. And so we're going to show you guys today is a solution. We won't spend quite as much time getting into the weeds of the solution, but we have a multi-agent design. So there's a supervisor agent that is coordinating between several different domain-specific agents. So we have a billing agent that can answer billing questions. We have a product agent that can answer product-type FAQ questions, so on and so forth. And so kind of taking this application and tying it back into the generative AI lifecycle, what I want to lay out is there's really 4 personas that are involved with building GenAI applications. So over here on the far left, obviously we have the users, right? The people are actually using the application. Next, we have the developers. So we have Niall and team here. And then finally, we also have subject matter experts, right, to be able to evaluate and determine if the answers are right or wrong. And then we have business analysts. How else are we going to know if the KPIs went up if we don't have someone who's able to do that type of work? So this framework I'll kind of use throughout the entire talk to help kind of put the pieces together and show you the workflows, and show you how MLflow helps. So kind of remember this structure. So first milestone that we're going to get into is, we've been funded. We've got a small team of developers. We've laid out kind of the requirements. We wrote a requirements document, and we need to build the prototype. And so in building this prototype, the first challenge that we're going to face is, Niall's great at software engineering and GenAI development, but he's unfortunately not an expert, as I mentioned, in the call center space. He doesn't know what the right answer to a billing question is. Neither do I. So we actually need to be able to iteratively, collect feedback from our subject matter experts and understand when they say something's wrong, what actually happened in the back of the application. And so to do this, kind of bringing back the generative AI lifecycle here, we're going to have our testers, and we're going to have our agent, and we're going to implement MLflow tracing. And so MLflow tracing is our comprehensive observability solution. What you can do is you can put one line of code into any application deployed anywhere, whether it uses OpenAI, LangGraph, Llama Index, any of the 20 or so popular frameworks out there. We'll instantly grab the full observability data, every step that happens, what tokens were used, what documents were retrieved, so on and so forth. But we have that. We need to link user feedback to it. And so MLflow also includes a scalable API called log feedback. And so what this is going to enable us to do is to take the user feedback from our front end and link it to the MLflow trace. So now we'll kind of show us how the application works and then show you a little bit of tracing.
Excellent. So at this stage, as Eric mentioned, we've built out a first version of our agent. And to help the team provide that feedback and to play around with the agent that we've deployed as an endpoint, we've stood up this pretty simple UI and have pre-populated a question that we can send to the agent. We can pre-populate it with customer ID. And really what we want to do here is provide those domain experts with the ability to ask any kind of query. We're going to hit that against our agent endpoint. We're going to yield a response, and then also give us the ability to then gather feedback according to that. So while this generates a response for us, really what this is doing in the background is going to our agent, it's going to that supervisor agent, it's then determining which of the sub-agents should I use. And so in this case, we're hitting our customer our customer account information sub-agent, which has tools to retrieve information. And so in this case, we can get a response back about our family plan, about a premium family plan. And as a domain expert, I'm kind of looking at this and I'm saying, okay, it's kind of almost all the way there, but I want to just provide some negative feedback. So I'll give this a thumbs down. I'll send that. What's then happening in the background is that we're capturing that trace. And as Eric said, instantly we can also then attach feedback to that trace. So in the background, where this is going, and I'll just show you where exactly this then sits. Everything here is, you can think of this as containerized to an experiment. So within Databricks, I'm going to go down to my experiment. I'll grab the underlying experiment for this. I'll just look within the last hour to see what's come through. And instantly what you see is that request comes through. So I'll just separate this down first and kind of do a bit of an anatomy of the trace. So we're not going to go too deep in the weeds on the actual agent itself. But broadly, what you get initially is this summary. And think of this just as the steps. And so whenever we add in that decorator syntax, what we can do is say, what are the steps throughout the agent? And we can see it's rooting the query, it's classifying the query. We're then calling an LLM, calling a tool. We can go into the details itself and also the timeline of how those are executed. And really what this is showing is that we're routing to an account agent. The account agent is then handling that query. We're then yielding a response. And what we get is the output that we saw in the UI. How do we then attach that to the feedback that we're collecting? So instantly, whenever we are providing that thumbs down, we're using that same syntax that Eric just showed to be able to collect that feedback, attach it to a trace. So here we see that thumbs down. We could also attach some qualitative information to that as well. So at this stage, what we have is the ability to give our stakeholders, our domain experts, the ability to query the agent endpoint, to submit a request. We get a response. On our side, we can see step by step what's happening, and we can also then attach that user feedback to it. So at this stage, I turn back to Eric and I say, hey, we're in a good place to at least let people play around with this to collect feedback on it.
Great. So, at this point, we're in the development. We started testing kind of a small handfuls of questions. We have a pretty good sense that at least directionally the application works. Right? We have a viable POC. But at this point, what we need to do is we actually need to launch it to maybe a slightly larger pool of users, some trusted testers that we have. And in this trusted tester launch, we'll probably launch it to about 100 or so users for them to try it out. And in this, what we really need to be able to do is we actually need to monitor and identify where issues are happening. And so previously, it was actually reasonable for myself and Niall to read through the questions, right? In fact, we wanted to. We wanted to kind of get our heads around the problem. But at this point, we'll be having hundreds to thousands of queries coming in each day. And I don't know about you, but I don't have time to read 1,000 queries and determine exactly what's going on. And so this is really challenging. How do I actually monitor these? And it's not just simple monitoring. It's not like yes or no. There's a full string, right? There's the inputs, and I'll show you these traces. They can get pretty complex. And so kind of coming back to our life cycle here, with MLflow, we've got our traces instrumented and we have our user feedback instrumented. What we're going to add in here is we're going to add in the monitoring component. And so under the hood, what monitoring is able to do is it's able to use Databricks proprietary LLM judges. So what's an LLM judge? You can kind of think of it as a large language model that's been specifically tuned to be an evaluator. I really liked Ollie's analogy earlier today. He said, it's much easier to judge something than it is to actually generate something. And so that's kind of the intuition behind these models, right? You can know if it's a good or bad input. Now, out of the box, as many know, right, ChatGPT knows very little about your business, almost next to nothing. And so what we've done here is we've made it really simple to work with your domain experts, your subject matter experts, to create judges that reflect your business criteria. So we've got a few that are built in out of the box, like hallucination detection to make it easy to get started. But then we have a really easy to use SDK and UI to be able to add in business criteria. So in this case, right, one of the criteria that we've worked with the business to define is that obviously the response must actually fulfill the request. And so while this is a shortened version, just to keep it on the screen, right? You can kind of think of these as definitions of what good quality looks like, and then they're automatically run across all of your production traces so that you can know, and we can know where there are quality issues and dig deeper into them. So with that, I'll turn it over to Niall to kind of show you how this looks like in ML.
Great. So at this stage, where we left off was just looking at an individual trace, but let's roll this back for the last 7 days. And what we're going to see then are the various requests that are coming through, our responses. And what we can see is we can dig into each of these. So each request here, underlying that are the traces. And as Eric said, what we have done is we've worked with our stakeholders, our domain experts, to define these scores. And what that will allow us to do is convert that business logic into some set of rules that we can then provide to the score and generate an assessment. So I'm just going to click a few of these. You can see we've got a whole suite of these, but just a cherry pick. So I'll include our user feedback, but I'll also include tool success, query resolution. And you can think of these just as an LLM judge that is assessing, is taking really the trace itself and is going through the trace and saying, okay, given the response here, have we resolved the query itself? And what this allows us to do is kind of slice and dice our traces that are coming through. And if we have a look at this, we can really filter down to some of the things here. So we can filter down on user feedback, tool success. Let's have a look then at query resolution. So if I dig a little bit into what queries are not being resolved successfully. And another thing that we also get out of the box is for each incoming query, what monitoring will also do is automatically attribute a topic to it. So think of this as a bucketing of what are the topics that we're seeing come through. And this can really, again, allow us to slice and dice and zone in on certain types of queries that are coming through. So if I just zoom out on this, I can go and see that there's user inquiry queries that are coming through. And in particular, if I just roll this up, what we can see is that we can almost triage the problematic queries here. So just to play this out again, what we're looking at is the feeling according to the judge, the query resolution, like what queries are not being resolved, and then we're digging in on what specific topics. And immediately, those with a keen eye will see that, okay, we're generating weird responses here. Max iterations 10 reached. And what, again, we can do here is go and dig into an individual trace. And just kind of immediately, as a developer looking at this, I know that the way that I've implemented this billing agent is to use a billing tool to be able to retrieve certain information. So can you tell me how many voice minutes I've used for this so far in the past 30 days? And immediately what I'm thinking is, okay, the way that I've developed this is to be able to retrieve billing information, but here it's asking me something about voice minutes, which I don't recall actually having, giving a tool to be able to retrieve that. So what we're seeing here is within this billing agent is repeatedly trying to call get billing info. And immediately what I'm seeing is, okay, there's something that doesn't look quite right here. It's repeatedly calling billing info. The actual response that I'm getting from the assistant is this max iterations reached. And upon seeing this, again, having worked closely with the team, I recall, okay, we don't actually have usage information included as a tool for the agent to retrieve. So think of this as the agent itself, the request is coming in, it's going to the supervisor. Supervisor is then attributing to the billing agent. The billing agent is trying to use a tool which it doesn't have, or trying to retrieve information it doesn't have. So we need to equip it. And working with that team, I then come up with a team to say, okay, is there information that we can actually use to answer this type of query, this usage inquiry information? We work with that team. We then figure out, okay, there is a way of us actually creating a tool that allows us to do this. And what I'm going to do is just zoom in on our catalog. We work with that team to come up with this tool that allows us to get usage information. so get usage info. And broadly what this is just a SQL query that allows us to retrieve that information. So we do a next version of the agent, we equip it with this tool, and on doing this, what we're then able to do is say to Eric, okay, I've tested this in a notebook. It actually looks good. It looks like the vibes are good whenever we test it in a notebook. I think we're good to go.
Awesome. So just to, it's like, now, didn't we talk earlier? We're not going to test things on vibes.
Wait, ready?
But jokes aside, right? Like this is a pretty common situation for customers, right? There's a set of requirements that came from a small number of experts, and they said the agent needs to do X, Y, and Z. When real users actually end up using that agent, the queries are different, and they're changing over time. And so what we're able to do here is we took the criteria that our business stakeholders gave us and codified it into automated metrics that allowed us to identify these issues at scale, right? You can see, in the demo, we were able to kind of pinpoint down to exactly what was going on without needing to read hundreds upon hundreds of queries. So it's really, really powerful. But, it's great that Niall, is kind of familiar with the application and he thinks the vibes are good, which is fair. But, back to kind of what we talked about earlier, I don't think I could go back to our CIO and say that we're going to deploy this off of Niall's vibes. I don't think that's an acceptable answer at this point in the application lifecycle. And so what we really want to do here is, just like in software, we want to say, well, did it work? Like, did it actually solve the problem? And then two, what Niall didn't highlight was that, yeah, 20% had a problem, but 80% were good. So I don't want to make those go bad just because we put this new tool in place. And so what we need here is we need a solution that allows us to see if it solved the problem and check regressions. And so, kind of in the theme of this talk, right back to how MLflow is able to help you here. What MLflow allows you to do is essentially, we allow you to take the MLflow traces. So we can curate some of the examples of these traces that were not working, had max iteration 10, and we can create what's called an evaluation data set. So essentially, you can think of it like a unit test suite, but rather than being a bunch of code that you write, it's a plain text or plain English inputs. So we'll curate that into an evaluation data set, and then we'll use MLflow's GenAI evaluate command, which essentially will call our application, new application version, for every input in that data set, and it'll run those same metrics that we defined and we're using to identify quality issues. And so what we're able to do here is, one, we can test the fix with that set of traffic that we saw at the issue. And then we'll also create another evaluation data set that has some of the questions that were working well, and then be able to verify that we don't have a regression from the new fix that Niall put in place. So we'll be able to do this without vibes, and hopefully we'll be able to keep our jobs as a result of doing this. So now we'll kind of walk through how this looks in practice.
So just to pick up where we left off, we've been able to, at least in a notebook, to vibe check it to see, okay, we're actually able to fix it. But as Eric said, how do we create that kind of unit test and regression test using our eval set? So where we left off was we had triaged these queries where our query resolution judge was failing. And what we can do is actually select these. And I'm doing this via the UI, but you can do this programmatically. We can select an action to add to an eval data set. I would create a new data set, choose my schema. I'll put it into, well, I wouldn't put it into our prod one, but for all intents and purposes, selecting a schema for us to then add it to, confirming it, selecting a table name, and creating that eval set. What we can then do is, in an offline setting, we can go to our notebook, we can set our MLflow experiment, select our eval set name, so in this case, our specific usage inquiry tools. So think of this as just, what are those failing requests that we see coming through? We select our endpoint name, so I've deployed a new version of our agent to the endpoint with that ability to use the usage tool. We define a score or any number of scores. So in this case, what does our query resolution score look like? And it's just a case of providing guidelines. Response must be partially or fully answering the request. And we can then run over that eval set. Once we run that, because we have set the experiment, again, think of the experiment as a kind of container where both our monitoring information, our traces, but also these eval runs that we can also track back to. If we navigate back to our experiment, we tab over to evaluations. I'll first point you to one of those initial runs that we did against our usage inquiry eval set. And what we're able to do is, again, slice and dice via the different assessments that we have. So what we have brought up just at the minute are things that are out of the box, like cost, input tokens, latency, output tokens. But what we also have then is query resolution. So was the response resolving the initial query of the user? And what we can see is for the initial agent, so without the ability to retrieve that information, we again see that we are failing according to that judge. Sorry, just to bring back to evals. And with the fix, what we can then do is to run it again, but against our eval set. We can go into that individual run, but what we can do is compare it to our baseline run. So we run it without the ability to use that tool. We then run it with the ability to use that tool. We compare these two things. And what we can do is compare the two runs against each other. So we see initially max iterations throughout all of these. So it's repeatedly trying to call a tool it doesn't have information to. And what we can then see is our query resolution significantly then jumps up. So having given the ability to use that new functionality, we now see that for this specific set of usage inquiry queries that we have provided, it's now able to pass a lot of those. But as Eric said, okay, it's not quite good enough for it just to pass this cherry-picked set of examples. We want to make sure that whenever we make that change, it's not affecting other parts of the agent. It's not affecting its ability to answer other types of queries that we know we're already performing okay on. So what we can also do is in a very similar process, instead of just subsetting down to the set of queries that we know are problematic, we can span across all the different topics. So say we want to look across the past 7 days. I'll just get rid of the topics so that we can see all of this. What we could do is we could select, and we can do this either, again, via the UI. We could do it programmatically that we want to randomly sample some selection of these. But again, we could create another eval set and have that almost as our kind of regression test to say this is a broader set of queries that we still want to perform to a significant level against. And it would just be the same process of going to evals, running our initial run of without the change, and then running with the change. And so here, again, as you would see, is the ability to run that evals against the non, without the ability to have the tool, and with the ability to have the tool, and we can, again, do that comparison. So with this, I then say to Eric, okay, we have the ability to both unit test our agent, to regression test our agent. I think we're now in a good place to progress to a broader set of users.
Awesome. So kind of back here, right? Like, we walked you through one iteration of this, of using these evals to do regression tests and to do unit tests. But in a real life iterative AI application, right, there's not just going to be one issue. And so what we have now is kind of the ability to systematically test our agent's quality. And when we put fixes in place, we're able to check that they didn't cause issues again. So back to our life cycle here, right? We now have a replacement where we could, at least with a straight face, tell our CIO that we're able to test things and make sure that we haven't caused more problems with our fixes. So the next thing, I think at this point, right, we've gone through many more of these cycles. It's a demo, so we can't go through every single issue. But we need to know if the app's ready for production. And so I think kind of coming back to the use case that we had, right, the most important thing was not GenAI. The most important thing was, did I drive the business KPIs that our CEO cared about? Did we increase the customer satisfaction? Do we increase the amount of calls that resolve the first time they came in? And so that kind of brings us to one of the next challenges here is what we need to be able to say when we put this thing out to real users. Not only one, are we going to be able to, do we need to say, hey, how can we actually, sorry, how do we actually say, like, is the quality good? But also, did it actually drive our business KPIs? And right, so in terms of being able to check if the quality is good, because we have that eval suite that we already use, we can, with MLflow, we can just run that in production and continuously sample a percentage of our traffic to be able to check that we have good quality. But in order to actually link it to our business metrics, right, what we want to know is, hey, for the users of this agent, did the KPIs go up for them? And this is it's a data problem. We need to have bring our business analyst team in. They own this dashboard. And so what we need to do is link. And so with MLflow, because it's integrated into Databricks, all of the data that we just talked about, all of the evals, all of the traces, it's available in the lakehouse. So with that, we can not just look at correlations. We can actually deterministically link our call center data with our GenAI agent data. This is really, really powerful, kind of, again, all on top of building on top of the lakehouse paradigm. So with that, I'll quickly turn it over to Niall to see how our agent's doing in production.
Yep, so where we are at the minute is we've rolled it out to a limited set of users. We've gone through the kind of internal domain testing. We're collecting traces. And as Eric said, it becomes a kind of simple SQL join for us to go from existing metrics. And at the start, what we were talking about was, okay, what is the CSAT score? So the customer satisfaction as those incoming queries from real users are coming in, and also first response rate. So think of this as our queries coming in from customers resolved on first response. And so this is just showing that over time, those agents, those customer service agents that are not using our AI agent, and as we come in and deploy our agent and those kind of limited set of users begin using it, we see an immediate then uptick in our CSAT scores, but also our first response scores as well. And really the thing to emphasize here is just the ability to say, we're collecting all of those traces. Once we are also collecting that feedback, it just becomes a kind of simple join between these two things. So all looks good here, Eric. I think we're good to move forward. We're good to roll out to more users. And we're ready to develop more features as well.
So thanks. So I guess, yeah, with that we'll kind of summarize. But right, I think the salient point here, right, is that we have all this data available to us. It looks and feels just like any other data inside our lakehouse. Yes, MLflow has a nice UI on top, has specialized SDKs to make our developers more productive. But at the end of the day, it's data. And that data sits in our lakehouse and is enabled, and we can, like Niall said, it's a simple join away from all of our actual business metrics. So it's really powerful to be able to actually look at business impact from your GenAI applications. But what I'll do now, we have a few minutes left, and I'll try to leave some time for questions. So in summary, we talked about our GenAI app lifecycle. We've got 4 key personas that we need to work with, and we need to enable them to collaborate and use data. And so what we did at first was we instrumented our application, and we enabled us to be able to debug and see user feedback interactively. Next, we set up monitoring so that we could identify and look at quality issues at scale during our initial testing. The nice part about this is that actually we didn't have to do any work later. We already had monitoring set up for our real production launch. Then, because we had this MLflow data, we were able to link it directly to our dashboards to set up business stakeholders or set up business KPI dashboards. And then once we found issues and we needed to test issues or test fixes to those issues and make sure we didn't have regressions, we used evaluation data sets curated from those traces along with MLflow's evaluation capability to give us the software development lifecycle, but designed for the nuances and the challenges of GenAI. And so kind of coming back to the theme throughout the talk, right? How do you apply software development best practices to generative AI? What we have here is we have offline evals, and we have production telemetry with evals included. And so it's a really nice unified online-offline solution where you're able to complete that lifecycle and actually deliver business value with generative AI. And more so than delivering business value, you can actually go with a straight face to your CIO and tell them that you have testing and you have monitoring in place, and you have confidence that you're not going to create more risk for the business by delivering inaccurate answers in your GenAI application. So this kind of one kind of even more simplified slide if you want to take a picture of it, right? This is what we view as kind of the virtuous cycle of improvement. You know, you have your application, your users are using it, MLflow traces and feedback come into monitoring with our LLM judges, allowing you to curate evaluation sets, test and continue to improve quality, and continuously iterate on and deliver value through generative AI. So with that, MLflow 3, it's out today. If you are an existing Databricks customer, it's in your workspace. If you're not a Databricks customer, and on this QR code, there's a link to sign up for kind of get started for free with MLflow on a Databricks account, and our docs as well as our website. So yeah, encourage you all to check it out. I think we saved 3.5 minutes for questions. So any questions?